Icebergs! These massive chunks of ice adrift in the ocean are a captivating sight. They come in all shapes and sizes, from small bergs to towering giants. But here's a curious fact. Despite floating in saltwater, icebergs are actually freshwater. How can this be? We often associate ice with freezing water, and rightly so, but the ocean is salty. So why aren't icebergs salty too? This leads us to an intriguing scientific exploration of their formation, the properties of seawater, and the unique process that keeps them mostly salt-free. Understanding why icebergs are freshwater goes beyond simple curiosity. It unveils the fascinating interplay of natural processes on our planet. It also highlights the impact of these icy giants on ocean currents, marine life, and even global climate patterns. Join me as we dive into the world of icebergs, uncovering the secrets behind their freshwater nature and exploring the broader implications for our planet. To understand why icebergs are freshwater, we need to first understand their origin. Icebergs are not formed from freezing seawater. Instead, they originate from glaciers, vast rivers of ice that form on land over thousands of years. Glaciers are born from the accumulation of snow. As snow falls and compresses over time, it transforms into ice, creating these massive, slow-moving rivers of fresh water. These glaciers, under the force of gravity, flow towards the ocean. Upon reaching the coastline, the leading edge of the glacier, often jutting out over the water, becomes unstable. The immense weight of the ice, coupled with the relentless push from behind, causes large chunks to break off and plunge into the sea. This process is known as calving. These colossal chunks of ice, now independent entities, are what we call icebergs. They embark on their own journeys, carried by ocean currents and winds, until they eventually melt and merge with the sea. The formation of glaciers, the parents of icebergs, is a captivating process that unfolds over millennia. It all begins with snowfall at high altitudes or in polar regions where temperatures remain consistently low. As snow accumulates year after year, the weight of the overlying layers compresses the lower layers. This compression forces the snow to recrystallize, transforming it into denser, granular ice called firn. Over time, as more snow falls and the firn layer thickens, the increasing pressure forces out the trapped air. This process transforms the firn into glacial ice, a dense, tightly packed form of ice. This glacial ice, under its own weight, begins to flow slowly downhill, much like a very slow-moving river. This flow carves out valleys and shapes landscapes, leaving a lasting impact on the terrain. Calving, the dramatic process of iceberg birth, is a testament to the immense power of nature. It's a spectacle of sound and fury, as colossal chunks of ice break away from glaciers and crash into the water. As glaciers flow towards the ocean, their leading edges, known as ice tongues or ice shelves, extend over the water. These extensions become increasingly unstable as they reach further out, susceptible to the relentless forces of the ocean. The combination of factors like rising air and water temperatures, ocean currents, and even tidal activity can weaken the ice shelf, creating cracks and fissures. Eventually, the weight of the ice itself becomes too much to bear. With a thunderous roar, a massive chunk of ice breaks off, creating an iceberg. This calving event not only reshapes the glacier, but also sends ripples through the surrounding environment, impacting ocean currents and marine life. Section 5. Why aren't icebergs salty? Now let's address the central question. Why are icebergs freshwater despite originating from a salty ocean? The answer lies in the unique properties of water and the way it freezes. When seawater freezes, it doesn't incorporate the salt into the ice crystals. This is due to the molecular structure of ice. Ice crystals form a lattice-like structure, and the spaces within this lattice are too small to accommodate salt ions. As a result, the salt gets pushed out during the freezing process, concentrating in the remaining liquid water. This process is known as brine rejection. The rejected brine, being denser than the surrounding water, tends to sink. Therefore, the ice that forms from freezing seawater, known as sea ice, has a much lower salt content than the surrounding water. However, it's not entirely salt-free. Some brine can get trapped in tiny pockets within the ice. Section 6. The salt of the sea. Salinity and its significance. Salinity, the amount of dissolved salts in a body of water, is a fundamental property of seawater. It plays a crucial role in various ocean processes, influencing everything from ocean currents to marine life. Seawater salinity is primarily due to the weathering of rocks and minerals on land. Over millions of years, rivers have carried dissolved ions, primarily sodium and chloride, into the ocean, contributing to its saltiness. This salinity gradient, the variation in salt concentration, is a driving force behind ocean currents. Denser, saltier water sinks while less salty water rises, creating a continuous circulation system that distributes heat around the globe. Moreover, salinity plays a vital role in marine ecosystems. Different species of marine organisms have adapted to thrive within specific salinity ranges. Changes in salinity can impact their survival, reproduction, and overall health. Section 7. Brine Rejection: How Icebergs Stay Fresh. While sea ice contains some salt, glaciers and subsequently icebergs are formed through a different process that renders them practically freshwater. This is where brine rejection comes into play. As mentioned earlier, glaciers form from the accumulation and compression of snow over thousands of years. This snow, falling from the atmosphere, is essentially fresh water. Any impurities or salts present in the snowfall are minimal. During the compression process, as snow transforms into glacial ice, any remaining impurities, including trace amounts of salt, are squeezed out. The resulting glacial ice is therefore incredibly pure, with a salinity level close to zero. When glaciers calve and release icebergs, these icebergs retain the freshwater purity of their parent glacier. The brine rejection process during glacier formation ensures that the icebergs are essentially giant chunks of fresh water floating in a salty ocean. Section 8. The impact of icebergs. From nutrient transport to ecosystem shifts. Icebergs, far from being passive chunks of ice, play a significant role in the marine environment, impacting ocean circulation, nutrient distribution, and even the distribution of marine life. As icebergs melt, they release fresh water and any trapped nutrients into the surrounding ocean. These nutrients, accumulated over millennia in the glaciers, act as a fertilizer, promoting phytoplankton growth, the base of the marine food web. The melting of icebergs also influences ocean currents and water density. The influx of fresh water can alter salinity gradients, impacting the circulation patterns that distribute heat and nutrients throughout the ocean. Moreover, icebergs can serve as temporary habitats for various marine organisms. Seals, for example, often use icebergs as resting platforms, while birds might utilize them as nesting sites. Section 9. Fascinating iceberg facts: size, shape, and longevity. Icebergs, beyond their scientific significance, are objects of fascination, captivating our imagination with their sheer size, varied shapes, and surprising longevity. The largest iceberg ever recorded, dubbed Iceberg B-15, was larger than the island of Jamaica. These behemoths can tower hundreds of feet above the waterline, with their vast majority hidden beneath the surface. Icebergs come in various shapes and sizes, from tabular, flat-topped, and blocky to wedge-shaped and pinnacle-pointed. Their unique shapes are sculpted by wind, waves, and melting processes. While most icebergs melt within a few years, some can survive for decades, depending on their size, shape, and the surrounding ocean conditions. These icy wanderers can travel vast distances, carried by currents and winds. Section 10. Debunking iceberg myths, separating fact from fiction. Icebergs, shrouded in mystery and grandeur, have inspired numerous myths and misconceptions. Let's debunk some of the common ones. Myth: icebergs are only found in the Arctic and Antarctic regions. In fact, while most icebergs originate from glaciers in polar regions, they can drift into warmer waters carried by ocean currents. Myth: icebergs are always white. Fact: while predominantly white due to trapped air bubbles, icebergs can exhibit stunning shades of blue, green, and even black depending on the ice density, mineral content, and light conditions. Myth: you can only see the tip of the iceberg. Fact: while the common saying holds true, with about 90% of an iceberg submerged, the visible portion can still be massive, reaching hundreds of feet above the waterline. Section 11. Conclusion: appreciating the wonders of nature. Icebergs, these magnificent creations of ice and time, offer a glimpse into the intricate workings of our planet. Understanding why they are freshwater unveils the fascinating interplay of natural processes like glacier formation, brine rejection, and the unique properties of water. Their impact extends beyond their icy presence, influencing ocean currents, nutrient distribution, and marine ecosystems. As we marvel at their size and beauty, let's also appreciate their scientific significance and the role they play in our planet's delicate balance. From their formation in the heart of glaciers to their journeys across vast oceans, icebergs remind us of the awe-inspiring power and complexity of the natural world. By seeking to understand these phenomena, we gain a deeper appreciation for the planet we call home.